your test will cover Chapter 8, Part 1. We will go into Part 2 a little bit today, but your test, 1 week from today, next Monday, will cover Chapter 8, Part 1. Okay? What will happen next week is the same thing that happened when I gave you that little mini quiz, is you'll come in here and I'll probably lecture for about an hour, and then after that hour, I'll let you take your quiz or your test. All right? So, my hopes for today is to finish Part 1, go into Part 2, and then also review for your test next week. That's my hopes for today. All right, so we started talking about 2 weeks ago. I know y'all probably don't even remember this. Combining functions. And if you remember, a function is nothing more than a polynomial, basically. Well, it can be written in other ways. For example, this is a linear function. But basically, we started talking about adding functions, subtracting functions, multiplying them, and dividing them. And on your test, what I'm going to ask you to do is I'm going to ask you to add, subtract, multiply, divide, and I'm also going to ask you to tell me the domain of your answer. So we are going to have to go through that as well. And then the last thing we'll talk about is the compositions, and we'll talk about that in a minute. Now, look at number 4, and number 4 is the only one that you really have to worry about. Number 4, when you divide these functions, you have to make sure that your domain or your denominator is not going to be 0. And remember, that's exactly how we're going to find that domain. So for number 4, if I ask you what the domain is, remember what you have to do. You have to take that denominator and set it cannot be equal to 0. And when you solve, your domain is going to be what? Is it going to be 4 or anything but 4? Anything but 4 is what your domain is going to be. Okay? And so when you write that on your answer blank, it doesn't matter to me how you write it. Like I told you in the back of the book, you're going to see it written in set notation, and that's not required for me. Seriously, if you just write any number except 4, I'm good with that. As long as I know that you know what x can be, we're good. Okay? So, let's try it for these two, just kind of as a refresher. We're going to add, subtract, multiply, and divide, and we're going to state the domain for each. So, let's start off by adding these. So, if we do f plus g, and when you see it, it's going to be f plus g of x. And so, that means that you're going to take your f function, which would be this one, and you're going to add it to the g function, which would be this one. So basically, you're adding a binomial with a trinomial. And when you do that, all you're going to do is combine like terms. That's all you got to do. And of course, it does need to be in descending order, so we'll start with that x squared in that trinomial group. And then we'll put those two x's together, so we have x plus a negative x, which of course is going to go to 0. And then we have a negative 2 plus a negative 2, which is going to be a negative 4. Now, for the domain, there was 3 things that I asked you to remember. Do you remember them from way back then? Can you tell me what the domain for this one would be?
Anything but 2.
All real numbers. This is going to be all real numbers. This answer for the domain is going to be all real numbers. And I know this for 2 reasons. Number 1, I don't see a radical. My function is not a radical. Number 2, it's not a fraction. So if your function is not a radical and it's not a fraction, then you can plug in any x you want. And so your domain is going to be all real numbers. Double bar R from negative infinity to positive infinity, or if you even want to write all real numbers, that's fine. All right, for the subtraction, f minus g. Now, we need to talk about the commutative property and which functions are commutative and which ones are not. Addition and multiplication, it doesn't matter which one comes first. But when you talk about subtraction and division, you have to pay attention to the order. Because if I had said for this problem g minus f, you would have to write the g function first minus the f function. Okay? So order does matter, so be careful with that. But this one says f minus g, so we'll take that binomial and we'll subtract the trinomial. Alright, so you have to remember your rules from Math 100 or your algebra, basic algebra, whatever your case may be. This minus sign goes to everything in this trinomial. Everything in this trinomial. So this is going to be a minus x squared, a negative x squared. And then here you have x minus a negative, which automatically goes to plus. So we have x plus x, which is going to be a positive 2x. And then you have a negative 2 minus a negative, which goes to plus 2, which goes to 0. So you have negative x squared plus 2x. So the domain for this one is going to be what? All real numbers, because it's not a radical and it's not a fraction. All right, so let's multiply. So we have f times g of x. So we're going to take this binomial and we're going to multiply it times the trinomial, which is just the distributive property. You should be able to do this without me. So let's take this x and multiply it through the trinomial. So x times x squared is going to be x to the third. X times negative x is going to be negative x squared. And x times negative 2 is negative 2x. Then we'll take this negative 2 and multiply it through the trinomial. So negative 2 times x squared is negative 2x squared. Negative 2 times negative x is going to be a positive 2x. And negative 2 times negative 2 is going to be a positive 4. So if we combine like terms, we're going to have x cubed minus 3x squared. X's are going to cancel out because you have a negative 2x and a positive 2x plus 4. So your domain, again, is all real numbers. Again, if your functions do not have a radical or a fraction, then it's just going to be all real numbers. All right, division. F divided by g of x. So we're going to have x minus 2 on top, and then on bottom we're going to have x squared minus x minus 2. Now, when you do division, I want to caution you, because sometimes this is not going to be your answer. What you have to do is you have to check to see if anything will cancel out. Well, you know, as it stands right now, nothing will cancel out, right? They're groups, okay? But look at that denominator. Will it factor? It will factor into, let's see, you have x plus 1 times x minus 2, all right? So these cancel out, and you're going to get 1 over x plus 1. That would be your answer. So if you wrote this as your answer, I might give you partial credit, but technically you have to check to see if that denominator will factor, so this would technically be your answer. So for the domain, what you need to do is you need to encompass everything that's not going to be possible. So for example, for your domain, you need to use this one. You need to set this one cannot be equal to 0. And we've already done the work, right? X minus 1, or x plus 1, and x minus 2. Neither one of those can be equal to 0. So we'll take each one. Cannot be equal to 0. So x cannot be negative 1. And x cannot be 2. So your domain would be any number except negative 1 and 2. So just remember, the addition, subtraction, and multiplication is fairly simple. But when you get to division, it can be simple, but make sure you check and make sure it doesn't reduce. Because if it reduces, you are going to have to reduce. Okay? Questions? All right, before we get to compositions, let's look into these compositions. Now, what I need you to notice is this symbol right here. This symbol is what's telling me that this is a composition. Basically what it's going to be is it's going to be an embedded function. Okay? So basically what it's saying is it's saying to take your f function and embed g into it. And for this one, you're just going to do the algebra. So basically, what it's saying is you're going to take f of x. And everywhere you see an x, you're going to substitute the whole entire polynomial of g. So watch this. For letter A, which says f composite g of x, and we call that fog for obvious reasons. Understand that's not the same as your multiplication symbol. It's an open circle. Okay, it is an open circle, so that is a composition. So this is what I like to do. The first variable that I see is f, and that's the function that I'm going to use. So I'm going to do 3, and I see an x there. Okay, 3x minus 1. So to plug in g, what you're going to do is you're going to do 3, and I'm going to make a skeleton where x is minus 1. Do you see what I did? I just replaced that x with a skeleton. Inside that skeleton is where g goes. So we're going to have x squared minus 2x minus 1. And that's your composition. From here, you just do the algebra. So we're going to do the distributive property. We'll have 3x squared minus 6x minus 3 minus 1. Combine your like terms. And you've got it. So 3x squared minus 6x minus 4 is going to be f composite g. Alright? So, let's try part B. Let's do g composite f of x. Alright, so g composite f. Again, what I'm going to do is I'm going to take the g function, and everywhere I see an x, I'm going to make a skeleton. Okay? So, here's an x squared. So we're going to do a skeleton squared minus 2x minus 2, and then open up a skeleton, and then finish it out with that minus 1. In the skeletons, I'm going to put the f function of 3x minus 1. So we have 3x minus 1 here, and 3x minus 1 here. So that's your substitution. Now what we're going to do is we're going to actually do the algebra. So 3x minus 1 quantity squared. What do you do? Yes, yay! Square, double square, or expand it in full. It's your choice, okay? You can either do 3x minus 1 times 3x minus 1 and pull it out, or know the pattern of square, double square. Take the first one, square it. Multiply these two together. 3x minus 1, or 3x and negative 1 is going to be a negative 3x, and double it. So that's going to be 6x. Always plus 1 squared, which is 1. Square, double square. And then we're going to distribute this negative 2, so we're going to have a negative 6x and a positive 2, minus 1. Combine your like terms, and we'll have 9x squared. Negative 6x and negative 6x is going to be negative 12x. And 1 and negative 1, those are going to be 0. Oh, thank you, yes. Plus 2. Alright, so what do you think about the composition? Easy. Easy enough. What about this? What if I throw fractions at you? What if I rewrite it differently? Okay, letter A. That says F composite G. That means instead of, look at the way it's written, okay? This is still a composition, it's just not using the composition symbol. But it's the exact same thing. And don't forget this, because when you get home and you start studying for your test, you may see it written like this, and you're going to say, Ms. Adams, you didn't say this is a composition. Yes, I did. Go back and listen to integrity. This is a composition. This says F composite G, because what it's doing is it's taking the F function and replacing the X with G of X, which is exactly what I told you to do. Okay? So A, F composite G of X. Everywhere you see an X, make a skeleton and plug in the G. This one you can't simplify. So that's going to be your answer. For B, this is a composition as well. This says G composite F. Take G, and everywhere you see an X, plug in the F of X. So G, make a skeleton for X, and plug in F of X. So from here, we can simplify this. What would the common denominator be? Common denominator is going to be X. So the first one's not going to change, is it? The second one, I have to multiply the top and the bottom by X. I don't know relative there. And then you can put them together over the common denominator. So that would be the answer for that one. So when you do these compositions, do your substitution, and then do your algebra, and then simplify it again. Okay? Before we go here, let's... Alright, so do you understand the difference here in what we did previously? We replaced X with an actual number in both instances. Here we replaced it with a 1/2, and here we replaced it with a 6. What's going to happen is this. You have one of two choices. You can go ahead and plug the 1/2 in once you set up your composition, or you can do your composition and then substitute in. And I'll show you both ways because it's completely and totally up to you. So the first one, notice it says do G composite F of 1/2. So the first thing I'm going to do is I'm going to do G composite F of X. So I'm going to take my G function and replace my X with a skeleton. And in that skeleton, I'm going to put in F. Alright, since everything is underneath the radical, what I'm going to do is I'm going to combine like terms. So I'm going to have the square root of 4x plus 2. Now what I'm going to do is I'm going to do G composite F of 1/2, which is what the problem's actually asking me to do. So you're going to do the square root of 4 times 1/2 plus 2. Well, half of 4 is 2 plus 2. And then the square root of 4 is simply 2. So what happens is, when you see this, you should actually get a number. You should actually get a number. And we're going to use this when you go into calculus. We will use this to find some other stuff. Sometimes you'll need the variable so that we can fluctuate things, and sometimes we're looking for the exact number. So again, my job is to teach you how to do this, and then calculus will actually apply. Alright, so let's look at F composite G of 6. Okay, it's not F composite G of X, it's F composite G of 6. Okay, so and I'll show you how to do this initially. F composite G of 6. What I'm going to do is I'm going to take my F function and I'm going to make a skeleton. And I'm going to plug in that skeleton, the G of X, but instead of X, I'm actually going to plug in the number. Do you see what I did? So if you want to go this route, you can. Okay? So whichever way is easier for you. If you want to do the composition and then substitute in the numerical value, that's fine. Or if you want to do the composition and substitute in the numerical value, that's fine. Just remember, if you're going to go this way, you're not going to plug in 6 to F. What you're going to do is you're going to write down F and make a skeleton just like you normally would. And then when you go to plug in G of X, you're going to replace that X with the 6. Okay? Alright, so let's practice this. Alright, so in Chapter 8, Part 1, we learned how to do the algebra of everything. Well, in Chapter 8, Part 2, what we're going to do is your most favorite thing in the world, which is graphs. So we're going to get to graphs. Do you need graph paper? That's completely and totally up to you. If you want to do junk graphs, that's fine. If you have my PowerPoints, you already have the graphs and you just don't even have to worry about it. On your test, 2 weeks from today, the graphs will be on the test for you. So you don't have to worry about graph paper then either. Alright, so the first thing we're going to talk about is your linear functions. How many of you know how to graph a straight line? Yay, you already know how to do this. Any function that can be written in the form of f of x equals ax plus b, we've already talked about this. This is called a linear function because it graphs a straight line. Watch this. F of x equals ax plus b is the same as f of x and y are the same. We talked about that. A and m are your slope. X is just an arbitrary point. And then b is your y-intercept. Okay? F of x equals ax plus b is just functional notation. It's workable notation. Y equals mx plus b is stuff that we've been using since 7th grade. Alright. Remember to graph a linear equation in slope-intercept form. What you're going to do is you're going to plot your y-intercept. And then you're going to use your slope to do your rise over run. Find another point. Connect the dots. Okay? So let's try this. F of x equals 2x minus 6. Where's my first point going to go? Negative 6 on the y-axis. Negative 6 on the y-axis. Alright, from here, from this point, don't go back to the origin. From this point, what are we going to do? Rise 2, run 1. So we're going to go rise 2, run 1, put another point. How many times can I do this? As many times as I want to, and you can see that it's going to make the same line. Rise 2, run 1, rise 2, run 1. So it is going to make the same line. I wish I had a straight edge, but I don't. So we'll do the best we can. Why the arrows? It goes on forever and ever. Very good. Okay. What about this one? It's fractions. Oh my goodness. Where in the world is negative 3/2 on the y-axis? In between negative 1 and negative 2. It's negative 1 and 1/2. It's negative 1 and 1/2. So we're going to guesstimate. We're going to use Miss Adams' method of graphing. If you can't hit it exactly, by knowledge, you better get it close. So negative 1 and 1/2. From here, what are we going to do? Down 3 and to the right 4, or up 3 and to the left 4. It doesn't matter which one you put this negative sign with. You can put the negative sign with the 3, or you can put the negative sign with the 4. But what do you not need to do? Don't put it to both. Okay? If you put it to both, that's going to make it positive, and we don't want that. Okay, so notice that we're in the halves. So when you start counting either down 3 and to the right 4 or up 3 and to the left 4, make sure you stay in halves. Okay, I'm going to go up 3 because it's rise to me, I rise. So we're going to go up 3, 1, 2, 3, and I'm going to run left 1, 2, 3, 4. And notice I'm still kind of sort of in the halves. And there's your line. I expect everybody to get a 100 on this, right? Graphing. Y'all been doing this since what, 7th grade? Is that when they start doing this now? What is this? F of x equals 3. You should know this from your piecewise functions. This is a horizontal line crossing the y-axis where? At 3. It's here. You should know that from your piecewise functions. We've already discussed that too. Okay, so let's get into something new. For some of us. Most of us, how many of you went through Algebra 2 in high school? Then you know how to do this. Most of you, well, yeah, unless it was back in the day. For me, it was back in the day, which actually I just did this last semester. But anyway, quadratic functions. Quadratic, when you hear me say quadratic, you know that it has one squared term, right? What makes a function quadratic? When you have one squared term. I'm not sure if that page number is correct because we've got new books. Obviously not. 421. 421. So if you look on page 421, when you graph a quadratic, what does it make? A parabola. A parabola. In this class, you're going to learn that that's not necessarily the case. It could be a U that goes this way. It could be an upside down U, but also in chapter, I think 13, we'll go this way and we'll go this way. So it could be a C or a backward C. All right. So basically, what I like to say, technically, is when you see a quadratic, it graphs a parabola. Okay? It graphs a parabola. So, in order to graph a parabola, the things that you need to know: vertex, very, very, very important. That's either your maximum or your minimum, your highest or your lowest point of your parabola. Okay, so you've got to know how to find a vertex. And let's make a connection right here and right now. This, right here, is called a standard form for quadratic. This is your standard form for a quadratic. And that's important. Because if you know the standard form of a quadratic, all you have to do is look at it and you can graph it really quickly. Because look, your vertex, it's a point, it's an ordered pair, an XY, but we call it HK. Why do we call it HK? Because look, right here's H, right here's K. So if you have a quadratic in standard form, you should be able to pick out the vertex. Right here's H, right here's K. But there's a little trick, okay? You see this minus sign in your formula? That means you have to take the opposite of what you see for H. So H is always going to be the opposite of what you see. K, you see the plus sign? You're going to take it as is. Okay? So this is the opposite of what you see. That's your X coordinate. And K is going to be exactly what you see. Now, all the way through this whole entire semester, when we talk about these graphs, HK, H is always going to go with X. K is always going to go with Y. Okay? H is X, period. K is Y, period. Okay? We're going to use this a lot in chapter 13, so make sure you remember this. Okay. A, in our linear equation, this was our slope. Here, it's your constant of your x squared term. It's just going to be the constant, your coefficient of your x squared term. If A is positive, your parabola is going up, like a cup. If it's negative, it's going down. Okay, if it's positive, it'll hold water. If it's negative, it'll lose water. And then what you need to know is two other points. Okay, so what do you need to know in order to graph a parabola? You need to know the vertex, whether it's going up or down, and two other points. Now, how you find the two other points is completely and totally up to you. I prefer using T-chart, but if I ask you, and you'll see this on your final exam, if I ask you to find the zeros of the graph, does anybody know what that is? What is that? Your x-intercepts. Very good. Okay? So, if I'm specific about this, if I say I want the vertex and the zeros, then you've got to be able to find the zeros. You've got to be able to find the x-intercepts. How in the world do you find the x-intercepts from a quadratic? Emily? We said equal to 0. We said equal to 0. And we did that in part 1. Remember when we took those denominators, we factored them, set them equal to 0? Remember that? Okay. So, vertex, whether it opens up or down, and then 2 points. And we're going to use the T-chart initially, but I will show you the quadratic formula or finding those zeros. So 2 points on opposite sides of the axis of symmetry. So let's talk about the axis of symmetry. If I have a parabola, and you'll notice that I am not a Picasso. If I have a parabola, and let's say that this is my vertex, the axis of symmetry will go through the vertex. Okay, so that is your axis of symmetry. It's just a vertical line going through the vertex. And when I say 2 points on the opposite sides, what you have to do is you have to find 1 point, and let's say that that's 3, 2. The other point, you don't even have to use the T-chart. You just find its mirror image. Because your axis of symmetry is the mirror, and so if there's a point to the right of the axis of symmetry, guess what? There's a mirror image to the left. So, to graph a parabola, you've got to know the vertex, you've got to know whether it opens up or down, and you've got to know 2 other points. I guess we'll go ahead and talk about this. If you have a function that is in standard form, then what happens is your HK has a horizontal shift of H units and a vertical shift of K units. That's common sense, because if you know how to plot a point, you know that this is going to go along your x-axis and this is going to go along your y-axis. Basically what that's saying is this, and we'll get into this later on. If you don't see a K, it's not shifting up or down. If you don't see an H, it's not shifting left and right. If you see an H, it shifts left and right. If you see a K, it shifts up and down. Okay? So, let's put this into action. F of x equals x squared minus 3. F of x equals x squared minus 3. Now, I'm going to, as we go along, I'm going to give you some hints, some things that you can look at to know what's going on. Do you see parentheses in this function? Do you see parentheses? Not in your functional notation, but in your actual function, do you see parentheses? No. Okay, let's go back to standard form. Which variable is associated with parentheses? Your h, your x coordinate. All right? If you don't see parentheses, guess what you don't have? You don't have an x coordinate, an h. So the vertex for this one, what do you think h is? You got to have one, but what number represents nothing? 0. Okay? If you don't see parentheses, you don't have an h. It's 0. In order to have an h, you've got to see parentheses. You've got to see this. Okay? H is going to be that number in there with x. But if you don't see parentheses, there's not one. So what do you think this number out here is? That's your y coordinate. Okay, so for your y coordinate, do you take what you see or do you take the opposite? And what tells you that? The plus sign in your formula says to take what you see. So h is 0, so what is k? Alright, so we have a vertex at 0, -3. So you can see, since I don't have an h, I didn't shift left or right. But since I did have a k, it told me to shift down. So you go 0, -3. So there's the vertex. What do you have to have in order to graph a parabola? Vertex. Does this one open up or down? How do you know it's up? What is A? What is A? 1. It's the coefficient of your x variable. A is going to be 1. It is the coefficient of your x squared term, I guess I should say. It's the coefficient of your x squared term. In this case, it's 1. It's positive. I don't really care that it's 1. I just care that it's positive, which means this thing is going up. What else do I need to know?
2 points.
2 other points. Okay. What I like to do is basically it's the T-chart, but not. Pick a number, any number, relatively close to 0, 3. I like that one. Let's go with 3. You could go with 1. What's the only number you could not use? Why? Because it's already up there. You see that? The only number that you can't use is 0, because you're already using it for your x value. So you choose any other point. Somebody said 3. I like 3. So what we're going to do in order to find y is we're going to do f of 3 is equal to 3 squared minus 3, which is going to be 9 minus 3, which is going to be 6. So you have an ordered pair of 3, 6. Where did this come from? It's your original problem. So what we're doing is we're taking the 3 that somebody just chose, and you have that same prerogative. You can choose any 3 you want to except for 0, and you're going to plug it into this function. And that's going to give you your y coordinate, which is 6. So we have an ordered pair of 3, 6. Now, you have options. You have options. You can either pick another number for x, but it has to be on the other side of your vertex. So in other words, you can choose any other number that you want to. Since we chose a number on this side of our vertex, I have to choose a number on this side. Okay? So you can choose any other number that you want to over here and do this again. Because all I require is that you have the vertex, whether it opens up or down, and 2 other points. Well, we have 1 point. You can either choose another x value on the other side to get the other point, but it has to be on the other side, or you can do what I told you earlier, which is what? Use that mirror image. Here's your axis of symmetry, right? Does everybody see that red dotted line? Your axis of symmetry is a vertical line that goes through your vertex. You don't have to draw it. I'm just doing it as a visual. So if I have an ordered pair here, can anybody tell me the coordinates for its mirror image? -3, 6. It's right there. So I have a vertex. I know that it opens up. I have 2 ordered pairs. Now what can you do? To the best of your ability, graph it. And there it is. This will take a while to wrap your brain around. It's a lot of stuff. Okay? There's a lot of ways that you can go. There's a lot of options. But what do I require? Number 1, you got to know vertex. Number 2, up or down. Number 3, 2 points. How do you get those 2 points? 1, you can use the T-chart and the mirror image. Or 2, you can use the T-chart twice. Completely and totally up to you. But if you use the T-chart twice for your second ordered pair, what do you have to do? Go to the other side of your vertex. You've got to choose x values on either side of your vertex. Don't go to the same side. If you do, you're only going to get 1/2 of your parabola. Okay? Let's go again. What do you see? You see parentheses, which tells me what? There is an H. If you see parentheses, there is an H. Do you know what H is? +1. Why is it +1? Here's your H. Why is it +1? You have to take the opposite. This comes from your formula. You have to take the opposite of the number that you see. Opposite of the number that you see. So here we go. You see a -1. So the opposite is going to be +1. Okay. Do you see a number out here all by its little lonesome?
No.
What does that mean? No K. K is 0. There's your vertex. Okay? H is the number inside of parentheses, but you got to take the opposite. K is that number that will be out there by itself. Because in the previous problem, look, we didn't see any parentheses, so we know there was an H, and then -3 is out here by itself. So -3 was your K. Look here. Here, you do have parentheses, so there's an H, and you got to take the opposite of it. But there's not a number out here, so that's 0. So there's your vertex, 1, 0. Which means we have a shift to the right, 1. You have a shift to the right, 1. H shifts everything right and left. K shifts everything up and down. Okay? What is A? It's the coefficient in front of your x squared term. If you don't see a number, it's 1. So this one's going to go in which direction? Up, because it's positive. All right, let's find a point. Choose a number, any number. 2? That's the one I heard first, so we'll go there. All right, so let's go with f of 2, which is going to be 2 minus 1 quantity squared, which is going to be what? 1. So your ordered pair is 2, 1. That's there. Okay? If I did not remember the mirror image, give me another point that, or another x value that I could use. -4. Or 0. Yes, 0 would actually be the mirror image, right? Alright, so if we do f of -4, we're going to have -4 minus 1 quantity squared. Goodness gracious, that's going to give us 25. That's way off the chart. That's way up here. Alright. That was like a V. I promise it's a parabola. What?
So there'd be a curve in there,
Yeah, this is the only curve that's in. Well, technically it's all curving, but anyway. Alright, so let's look at this one. What do we have? Everything. We have an H right here. We have a K right here. Because how do I know that? I'm comparing this to the formula. Okay? So here's your H. It's inside parentheses. If you have an H, it will always be inside parentheses if it's in standard form. Okay? Because we are going to talk about general form. So, here's your H. K is always going to be that number out there by itself. So the vertex, you have to take the opposite of H for your x coordinate. So what's it going to be? -2. And K is going to be exactly what you see, -1. So there's your vertex. We have a shift to the left 2 and down 1. Left 2 and down 1. What is A? A is 2. So is this going up or down? It is going up. So let's find a point. Choose a number, any number. 0 sounds good. Alright, f of 0. So we're going to have 2 times 0 plus 2 quantity squared minus 1. What's that going to give us? 7. Is that right? 2 squared is 4 times 2 is 8 minus 1 is going to be 7. So we have an ordered pair of 2, 7. I'm stupid. 0, 7. 0, 7. Okay, so let's use the mirror image technique because that's just the easiest way to do it. What is its mirror image? -4, 7. So how are they doing that? Well, watch this, guys. Here's your mirror. If we found an ordered pair 2 units to the right of our mirror, you have to have an ordered pair 2 units to the left. Have to. That's the whole point. Parabolas are symmetrical, and the mirror is your axis of symmetry. Alright, so this one's going to be a skinny mini. How do I know what makes it skinny? A. The bigger A gets, the skinnier, I know this is the opposite of what you think. The bigger A gets, the skinnier your parabola gets. The smaller A gets, like fractional or decimal, the wider your parabola gets. Just a bit of trivial information. Okay. You tell me. And Nick, you cannot speak. What's the vertex? What is the x coordinate of the vertex? -2. Take the opposite of what you see. Here's your H. And K is going to be 3. Good. Heather, you cannot speak. What is A? -1. So this is going to open down. Good. Pick a number, any number. That's fine. 0. So F of 0. And that's going to give you what? 2 squared is 4. You got to take the opposite, so -4 plus 3 is going to be -1, so you're right. So what would its mirror image be? -4, -1? Alright, so you can see that it does go down. And I know what you're sitting there thinking. You're sitting there thinking, man, this is so easy. Well, it's easy because I'm helping you do this, and I've been doing this for 20 years. Okay? The question is, can you do this by yourself? Alright, so on the piecewise functions, remember when we did the algebra for this, on the piecewise functions, what we did is we looked at the domains to figure out what numbers to plug in which function. We didn't really talk about the graph, but in this particular problem, you have 3 different separate functions, which means you have 3 different graphs on one coordinate plane. Now, this piecewise function with these 3 graphs, what's going to happen is this. You have to pay attention to your domain. So that's the first thing I'm going to draw. You do not have to do this, but I'm just going to show you what's going on. X less than 0. That first graph has to be, all of your x values that you plug into that first graph have to be less than or equal to 0.
Not in this one, it's just less than.
Oh, you're right. Less than, thank you, then 0. Okay, so that first graph, the x values that you plug in for that first graph have to be less than 0. Okay? For the second graph is going to be between 0 and 3, but not equal to 3. And then that last graph is going to be greater than. So do you see that those 3 domains have divided your coordinate plane into 3 different sections? Do you see that? Okay, the section to the left, this section right here, the only thing that can be graphed in this section is that first graph. The only thing that can be graphed in this second section is that first graph. The only thing that can be graphed here is that first graph. So how in the world are we going to do this? Well, if you know what your graphs look like ahead of time, it's fairly simple. But if you don't know what the graphs look like, then you're going to have to plug numbers in. Okay? So, that first graph, I know that it's a parabola. How do I know that that's a parabola? Because of this squared term. So I know that this is a parabola. And I know that the vertex for this parabola is where? We just talked about this. The vertex for this parabola is going to be 0, 2. 0, 2. So the vertex is going to be here. But x cannot be equal to 0, so we remember if it can't be equal to 0, you have to use an open circle. Do you remember that? And I also know that this parabola is going to go up or down. It's going to go down. So I'm going to choose an x value, an arbitrary x value. But that x value has to be what? Less than 0. So let's go with, I don't know, -2. So let's go with f of -2. So we'll have the opposite of 2 squared. Be careful with that negative sign. So this is going to give me what? 2 squared is going to be 4. The opposite of 4 is -4. -4 plus 2 is going to be -2. So I have an ordered pair of -2, -2. All right. So we have that portion of the graph. That's only one portion of it. I just taught you how to graph parabolas, so you should know how to do this. Okay? I'm going to do a different color. I'm going to put this one in red. It's this. But this one can be equal to 0. So I close it in at 0, but it cannot be equal to 3, so I open it up at 3. So there's the middle graph. Okay, in the third section, what is that? It's going to be a parabola, and we're going to make this one black because I've already used every other color. The vertex is going to be where? 0, -7. Can I plot that point? 0, -7 is right here. That's not in my domain. My domain is way over here. My domain is way over here. So let's pick a number that is in the domain. Where? Tell me a number. Don't choose 3. Just an X value. 4? Okay. So we're going to plug in 4 to that bottom one. So we'll have 4 squared minus 7. So 16 minus 7 is going to be what, 9? So we're going to have an ordered pair at 4, 9. That doesn't sound right. Oh, yeah. Oh, yeah. Duh. Okay. So this problem, or this graph, originated at 0, -7. And then it goes all the way up to here. So let's plot 3 just to see where our initial point is. Can x be 3, first of all? Yeah, x can be 3. So if we do 3 squared minus 7, what are we going to get? 2. So I have an ordered pair here, and I have an ordered pair here. And you close it off here because x can be 3. And there's your piecewise function. So you have a parabola for one set. You have a horizontal line for another set. And then you have a parabola for the other set. So you're only going to draw the graph for the section that your domain consists. If it's not in your domain, you can't draw it there. And that's your piecewise function graph. These are fun. These are a lot of fun.